Here are the questions we went over from the 5.1 homework. The first question was trying to figure out how to find the second angle for the second triangle from the angle in the first triangle. So first of all, when you have an angle side-side information given, that means you have an angle, a side next to the angle, and a side across from the angle. It's the side across from the angle that's the one that kind of switches, hinges back and forth to give us a bigger triangle versus a smaller triangle. Then when we use law of sines to solve this, we get an angle that's positioned here next to this opposite side, that's opposite from the side that's adjacent to the angle that was given. This angle we then use to find the other angle and side to solve the triangle. To find the second triangle, it's this first angle that we subtract from 180 to get the angle in the second triangle. And then that's the angle we use to solve the other angle and side in the second triangle. Number 26, if you try using the letters that are in the formula, it's going to mess you up because the formula that we looked at last time was an alpha with A and C. So you can't use the formula with A and C in the order that they are given in the formula because in this case, instead of alpha, we have gamma. So gamma is the angle, C would be across from gamma, and A would be next to gamma. So it's like the roles of A and C switch places in those formulas. It's more about where the numbers are located and not what letters they are. You have to interpret that. So you can re-letter your picture and your given information, or just change your formula so that it doesn't have the same letters as the triangle so that that's not confusing you. In this case, in problem 26, the side across from angle gamma that's given is smaller than, so C, is smaller than the side that's next to gamma, A, just barely, ever so slightly smaller, which gives us the two triangles. So the question we ask ourselves is the side across from the angle smaller than the side next to the angle, but not smaller than H. If it's smaller than H, it won't make a triangle at all. We'll have no triangle. So it has to be somewhere between H and A in size. Not in this case A, we used C previously, but somewhere between the length of H and the length of the side next to the angle. If C fits in that measurement, or the opposite side fits in that measurement, then we have two triangles. I hope that helps. Also, just to be clear on numberings, letterings, labelings, alpha is opposite side A, beta is opposite side B, and gamma is opposite side C. If it's easier, just go ahead, instead of using alpha, beta, gamma, use capital A, capital B, capital C for your angles. We went ahead and looked at question 51 from the homework. We have a tree that's plumb to the earth, more or less. So this green line here is representing the earth and the tree perpendicular to that. So that would be a 90-degree angle. But we're driving up a sloped road. And if you look at the box on the page with the homework, it talks about how that slope means a 7% grade is going up 7 feet for every 100 feet. Using those two numbers, 7 over 100, we find out that the angle for that inclination would be 4 degrees. So that would be that angle right in there. So together with the 90-degree angle, that would make this angle 94 total. So then the problem tells us the other angle of inclination to the top of the tree is 6 degrees. The distance from the road to the top of the tree is 500 feet. So we go ahead and we do our h over sine of 6 equals 500 over sine of 94 and solve for h, and we got 52.4 feet. The answer key that corresponds with this on section 7.2 from the old version of the book says approximately 53 feet. So I'm not sure what was done differently to get that, but I think we're close. The last one we went through was question 45, which had to do with finding the altitude of a climber that's being rescued. And the climber is sighted from two different points. This rescue crew is 15 degrees angle, sight angle. This one's 20. This rescue group 2 is 22 degree sight angle. So we end up using those angles, this angle subtract from 180 to find this angle, and these angles added together subtract from 180 to find this angle. And using this angle, we can find the length of this side of our triangle, which would be the distance of rescue group 1 from the climber. So we go ahead and use law of sines to find this side here. So here's the process. Sine of 7 divided by 0.5 miles equals sine of 58 divided by x miles. We cross multiply, we solve for x. So now we have x, we're going to use that to find h. Now h is just this little piece right here, the height of the climber from the altitude of the rescuers. So we have the sine of 15 degrees. We're now using this big right triangle instead of this little oblique triangle. So sine of 15 is opposite over hypotenuse, so h over x, or 1.5369. We cross multiply, we find the answer is 0.4 basically. The rescuers are a mile in altitude, so we add the 0.4 of the hiker plus the 1 mile height of the rescuers, and we get the hiker or climber at an altitude of 1.4 miles. The last one we looked at was question 39, just clarifying the fact that when you're doing area using side angle side, it doesn't matter what side angle and side you use. When I went through this example, I found side C. Side A was given. We calculated side C, and then we used A, beta, C. It would have been just fine, though, to find side B instead, and then use B and A and the sine of 150. Or if you really wanted to do more work, you could do B and C and then use angle 13 degrees instead. It shouldn't matter which side angle side you use, you should get exactly the same area for the triangle.